Hello everyone, it's Wilson here. Today I want to talk about integrating a rational function like this one. Um, this is a proper fraction because the degree for the numerator is less than the degree for the denominator. And so usually the way that we integrate this kind of function is to use the technique of integration by partial fraction decomposition. In other words, we want to decompose this rational function into partial fractions. And so to get started, we actually want to factor the denominator and see if it's factorable. If it's factorable, then we can actually decompose it into partial fractions with linear denominators. Okay, so let's do that. First, we are going to factor. First, we are going to factor the 3x squared plus x minus 2. And how do we factor this one? We are going to factor this trinomial as a product of two binomials. So we are going to start by writing as 3x and x. Why do we have 3x and the x here? It's really because the 3x times the x will give us the 3x squared. And so we also want to come up with two numbers that when we multiply, they will give us 2. And because 2 is the prime number, so you only have one choice, right? Which is 2 and 1. And the question is, so we put the 2 here or so we put the 1 here? We got to try, right? That's why it's called trial and error. So we can try the 2 here and then the 1 here. Okay, so now if you try it, then you are going to be getting 3x times the 1. That will give us the 3x, and then the 2x 2 times the x will give us the 2x, right? So in this case, we are actually able to get the coefficient of 1 for the x. And we want a positive 1 as the coefficient. So in this case, we want the 3x to be positive, right? So to have a positive sign. So 3x times 1 will give us 3x. And then the 2, right? Minus 2x. So that if we do the minus 2x, then we get 3x minus the 2x, that will give us the x. And then negative 2 times positive 1 will give us negative 2. So that works. Okay, so that's the factorization for the 3x squared plus x minus 2. Okay, so now we can start decomposing this rational function into the sum of two partial fractions. So let's do that. So we are going to start by writing down the 7 minus 8x right here. And then the denominator would be what we have there, right, from our factorization, which is 3x minus 2. And then the other one is going to be x plus 1. Okay, so we can decompose this into a, and then what do we get here at the bottom? It's going to be 3x minus 2, and then plus. So now the second one is the b, right? The a and the b are just some constants that we don't know yet. So we get the x plus 1. Okay, so now we are claiming that we can factor this, we can decompose this rational function into the sum of two partial fractions. And from here, we need to figure out a and b, because if we figure out a and b, we can actually integrate this function. We can also integrate that function. We can integrate both functions directly. We cannot integrate this original function directly. So all we need to do is to decompose into the two partial fractions, and then we integrate each one. Okay, so now that's the idea. How do we figure out a and b? To figure out a and b, we actually need to combine those two fractions together and then try to match whatever that you have on this side of the equation with whatever that you have on the left side of the equation. And then we can figure out a and b by solving the equation. So how do we do that? So in order for us to add the two fractions, we'll need common denominators, right? So how do we get the common denominator? That's our least common denominator, is actually just the 3x minus 2 and then the x plus 1. So all we need to do right now is to multiply the first fraction top and the bottom by something, and then also for the second fraction we do the same thing, and then we can put them together. Okay, so let's do it. So we are going to be getting 7 minus 8x right here. And then the bottom is still just that 3x minus 2 and then that x plus 1. Okay, so what about this a right here? We have the a and then we have the 3x minus 2, right? And now, what do we need to do? Because we're trying to get the common denominator, we need to multiply something here. What do we need to multiply? We need to multiply the top and the bottom by whatever that's missing from the least common denominator. So we just need to multiply by x plus 1 so that we can turn our denominator into this. So multiply by x plus 1. Same thing at the top so that we are not changing our fraction. And then now we do it to the second fraction. Oops. So we have so we are going to multiply also the top and the bottom by 3x minus 2, right? We're using the same idea here, 3x minus 2. Okay. The left-hand side is still just the same fraction, so we just keep copying it. We don't need to do anything on this side. So what do we get? We have the 3x minus 2, then x plus 1. And then on the right hand side, this time it's, do you see that they have the same denominator? So all we need to do is to put it as a single fraction now. So the denominator, it's going to be 3x minus 2, x plus 1. Okay, what about the top? The top is going to be a times x plus 1, and then plus b times 3x minus 2. Okay. Now, one thing that I want to point out here is that we are claiming that the two sides are equal. So if they have the same denominator, then the numerators must also be equal so that the two sides are equivalent, right? So in this case, we can actually say that 7 minus 8x is equal to the numerator on the right-hand side. So we actually have 7 minus 8x equals a times x plus 1 plus b times 3x minus 2. Okay, so now we have that equation. Then you may say, what do we do next? We are trying to figure out a and b by solving this equation here. And then you may say, how do we solve this equation? There are usually two ways to do it. But what we are going to do is to go with the traditional way of doing this problem. And sometimes we actually want to maybe use the other way to do it. Let me describe the two ways. One way is which is the traditional way, is to distribute the a, distribute the b, and then simplify the right hand side. And then once you simplify the right hand side, you are going to be getting a polynomial on the right hand side. And then because you're also getting a polynomial on the left, you can just match the coefficients. And then from there, you may be able to set up a system of equations that will allow you to find a and b. So that's the traditional way of doing it. Another way to do it is that we can plug in some x values in here so that when we plug in some convenient x values, what I mean by convenient is that if you plug in the -1 in here, that will actually make this term go away. So that's what we mean by convenient. And from there, we can actually figure out what b is, because the only unknown right now would be b if you plug in the -1 into the x, because you don't need to worry about the a when this becomes 0. Okay, it will actually be a good idea to use a combination of both. I actually show both methods in another video. If you haven't watched that, you can actually find the link in the description. Usually for more complicated problems, I would suggest using a combination of both, which will actually help a lot, right? So don't just stick with one method, learn both. That will be my advice. Okay, so now I'm just going to go with the traditional. So I'm just going to have 7 minus 8x right here. And that's equal to, what do we get here? We are going to distribute the a and the b, right? So let's do that. So we have ax plus a plus 3bx and then minus 2b. Okay, and then do you see what's going on here? We have the x term. We also would have the x term right here. Okay, so we have the x term. And then we also have the constant terms. Okay, so the a here and then the minus 2b here. So what are we doing? We can combine the like terms, which will give us, so we combine the like terms, we are going to be getting, let me see, we have the a minus 2b. So that's actually our constant terms put together. And then plus, okay, now the blue terms, the x terms, which will give us a plus 3b. And then you are going to be, yeah, so there was the x. Do you see that you get a linear expression on this side? Remember the a and b are really just numbers, right? Just constants. So you get a constant term plus some number times x. And you have the constant term, which is 7, minus 8x, which is just some number times x. Do you see that you can actually match the coefficients? So a minus 2b is actually equal to 7. And then the a plus 3b is actually equal to negative 8 here. So see what's going on here? We have the a minus 2b is equal to the 7, and then the blue stuff, which is the a plus 3b, which is equal to negative 8. Okay, so now what do? We can set up a system of equations, which will now give us a minus 2b is equal to the 7. What about the other one? The other one is going to be a plus 3b equals the negative 8. So now you have those two equations. Equation 1 and equation 2, I usually would just label them this way. Okay, so what do we do right now? You all know how to solve a system of two linear equations with two unknowns, right? So what we can do is that we can actually use equation 2 minus equation 1, right? So you do that, equation 2 minus equation 1, then you are going to get a minus a, we get 0. 3b minus 2, negative 2b, so we are going to get 5b, right? Remember, you're doing subtraction. So 3 minus negative 2. It's not 3 minus 2, it's 3 minus negative 2, so you're going to get the 5. And then on the right-hand side of the equation, you get negative 8 minus 7, which is negative 15. So see that that's actually quite simple to do. The b is equal to negative 3. And then what do we do now? We plug the b back into one of the equations, whichever one that's easier, then we plug it back in, and then we can figure out what a is. If you plug it back into the first one, then you are going to be getting a minus 2 times the b. B is what? B is negative 3 here. Okay. And then equals 7. Then if you're solving this equation, we get a plus 6, right? Negative 3 times negative 2 times negative 3, we get positive 6 equals 7. And so a is equal to 1. Okay, so we figure out a and b already. So right now, all we need to do is to plug it back in, and then we can start doing the integration. So now going back to the original integral, we do not really keep the original function anymore, because we are claiming that this function is equal to the sum of two partial fractions, right? So now we plug the a in there. So 1 is being plugged in here. So our integral becomes 1 over 3x minus 2 and then plus. Now there is a b. The b is actually negative 3, right? So we get negative 3 here. And then in the denominator is x plus 1. So see that if we are to integrate the original function, then we actually can integrate the sum of those two fractions, which are here. And now you know that there are two terms, right? We can actually break the integral into two. So we get 1 over dx, and then minus 3 times the integral of 1 over, because I factor out the negative 3 on the outside, right? So we get the x plus 1 and then dx. See that that's actually quite easy to integrate. So we are going to be getting, if you look at this one, this is actually going to be ln absolute value. Leave some space in the front. I will tell you what we need to put here. So we are going to be getting 3x minus 2. Okay, but remember that when you differentiate this function, you are going to multiply by the derivative of the inner function, which will give you a 3. And to cancel out the 3 here, because there was no 3 in the original function, so to cancel the 3, you actually need to multiply by the reciprocal of the coefficient of x, which will give us, what is that? That's going to be 1 over 3, right? So 1 over 3. And then continue, which is, now this one, the coefficient of the x is 1, so we don't need to, the chain rule is actually trivial, so we can just put down 3 times ln of absolute value of x plus 1, and then plus c. Okay, so that's it for this problem. If you like this video, please give me a like, subscribe to my channel, and share my videos to others. It will give me support to make more videos. If you have questions or have a topic that you want me to talk about, please leave me a comment. Thank you for watching this.